Hello, welcome to Subtraction TV, where maths is taught the easy way. Today on Subtraction TV, we are looking at fractions. And under fractions, we'll be looking at what fraction really is. We'll also be looking at the types of fraction, that is the proper fraction, like fractions, unlike fractions, and the likes. And also we'll be looking at how to simplify fractions, the addition, the subtraction, the multiplication, and the division of fractions. And also, last but not least, we'll be looking at Bodmas, where we'll have a question involving all the symbols or all the signs we use in math, that's the addition and whatsoever. So I want you to stay tuned with me so that we dive into it. Now, stay tuned. Fractions are defined as part of a whole. Fractions are defined as part of a whole. Now, fractions has two parts. That's the upper part and the lower part. So it is written like this: A, B, with a line in between them, a number up and a number down. So the top number is called a numerator, and the down number is called a denominator. Now, anytime we have a number written in a form like this, let's say 2 on 3, this is called a fraction. It is part of a whole. This is called a fraction. Are you good? Now, let's look at how many types we have as far as this fraction is concerned. Because we have so many different types of fractions. And I'll make it very simple for you to indicate whether there is a proper. Now, the first one, proper fraction. Now, under proper fraction, the best explanation I can give you under proper fraction is, now listen. Now, if you have a junior brother or a junior sister, and you are going to town with this brother or sister, and about reaching to the town, you tell your junior brother to carry you. So you are walking and you have your small brother carry you in town. What do people say? What do people say? People will say, hey, why do you want to kill the child? Do you want to kill the child? People will be against this, right? But if you turn out to carry your junior brother, now this one, people will not comment about it, because this one is okay, because the big man or you the big sister is carrying the small sister. So anytime you see a number whereby the small number is up and the down number is bigger, this is proper. This is a proper way of fraction. So that is why it's called proper fraction, because the big number is carrying the small number. Unlike this one, the small number carrying a number. Now, this small person carrying a big number is also another type of fraction called an improper fraction. Now, that's our second one. So it means that improper fraction is you, the big sister or brother, carrying the small brother or sister. Then improper will be the vice versa. Then that one will be the small brother carrying the bigger one. Something like 5/3. We can see clearly that the down number, called the denominator, is carrying the bigger number. And if this is a human being, a small brother and a big brother, people will complain. So that is improper. It's not accepted. You understand? But in maths, it is called improper fraction. But if you, the big sister, is carrying the small sister or brother, that one is accepted. People will not talk him down. So that is called what? And what? A proper fraction. And this is what? An improper fraction. Like fractions are very simple. Anytime we have two or more fractions, we have to look at the denominators. So let's look at this. If I have a over b as a fraction, a over b, and let's say c over d as a fraction, and I also have a over b and also c over d, c over b as another fraction. Now let's look here. Now, to differentiate between like and unlike fractions, we look at the denominators. Now, if the denominators are different, they are called unlike fractions. But if the denominators are the same, we call it what? Like fractions. Example for this is, if I have 2/3 and also I have 1/4, the denominators are different. So this is what? Unlike fractions. But if I have 2/3 and also I have 1/3, we can see clearly that the denominators are the same. the denominators here are the same. So this is called what? Here, it's mixed fractions. Now, and for mixed fractions, the example I can give is that, now, if you are walking in town and you see a man and the wife, the man and the wife is carrying a baby, that is mixed fractions. Why am I saying that? Because the man here becomes a whole number, 1. But the mother here is carrying a baby, so they are 2. So that is the small number and what? The big number. So mixed fractions are simply a whole number and a proper fraction. Because if this is not there, this is a proper fraction. So mixed fractions is simply a whole number and what? A proper fraction. That is mixed fractions. Addition of fractions. Now here, we will first look at addition and subtraction of fractions. Now, when a question is given to add or subtract, there are 2 things to look out for. Whether the denominators are the same or they are not the same. This is what I mean. So if I have 1 over 4 plus, let's say 1 over 3. This is a fraction. We are told to add this. And we also have another 1 over 4 plus 2 over 4. We can see clearly that this one, the denominators of both terms are different. And this one is the same. So the first thing to look out for is that are the denominators the same? If they are the same, we know how to go. There's a different way to go about it. And if they are not the same, there's a different way to go about it. Now let's solve the one that has the same or that are like fractions. Now, if the denominators are the same, it is telling you that the answer to have a denominator of 4. Then you add the top, because it's addition, then you get 3. So you get 3 over 4. The same applies to subtraction. If I have 1 over 4 minus 2 over 4. Now with the same thing, because the denominators are the same, our answer automatically will have a denominator of what? Of 4. Then we subtract the top. 1 minus 2 give you minus 1. So this is what you have. Because the denominators are the same, it's simple down like that. I hope it's clear. Now, if the denominators are not the same, that is where the idea of LCM comes in. Now, what is the idea of LCM? Now, the idea is that find the multiples of 4 and find the multiples of 3. After you find the multiples of 4 and 3, you see some common multiples in the multiples of 4 and that is the multiples of 3. And when that is done, we will also see that among the common multiples, there is one that is minor or smaller among the common multiples. That is the least common multiple. So let's look at that. Let's take that. So we look at the multiples of 4. Then we have 4, 8, 12, 16, 20, 24, 28, and so on. Then we also look at the multiples of 3, and of which that one is also 3, 6, 9, 12, 15, 18, 27, and the likes. Now, among these multiples, we can see clearly that we have 8 here, 12 here, and we also have 12 here. And we have 24 here, and 24 here as well. So those are the common multiples. So we have 12 and what? 24. But among these 2 common multiples, which one is the smaller one? 12. So that becomes the least common multiple. So that is 12. So that is the idea when we say LCM. That is the idea of it. I hope it's clear. So our LCM here is what? 12. That's the least common multiple over here. 12. Now how many times will 4 go into 12? It means that 4 times 4 gives you 12. And that is 3. And that 3, we multiply it by the 1. That's the numerator on the 4. Then plus. How many times will 3 go into 12? That is 4. So we multiply it by the 1 we have here. So we are going to get 3 plus 4 all on 12, and that will give us 7 over 12. That's our final answer. That's our final answer. So anytime the denominators are not the same, we call out for what? The LCM. We use the LCM to solve it. Now 7 on 2 minus 5 on 3. Now let's check our denominators. We can see clearly that our denominators are not the same. So what do we have to do? We have to use the LCM method. So if we look for LCM of 3 and that of 2, we will get an LCM of 6. Now, how many times will 2 go into 6? 2 go into 6 3 times. So that 3 times 7 will give us 21. Then minus, how many times will 3 go into 6? 2. 2 times 5 will give me 10. So 21 minus 10 gives me 11. Then I'll bring my denominator 6. So that is how it is done. So simple like that. So now let's look at the multiplication and division all together. We look at that together. Then from there, we move straight to Bodmas. For examples and multiplication and division. It's very, very simple. Now, when we are multiplying, there is a term I use, top by top and down by down. We multiply the one on top, that's the numerators, and also multiply the denominators. So 2 times 3 gives me 6, and also 5 times 4 gives me what? 20. That is all. We are done. Now when it comes to the division, what we do is we reciprocate the term on the right. We reciprocate the term on the right. What do I mean by reciprocate? The denominator tends to be a numerator, and the numerator tends to be what? The denominator. Then that will change the sign division to what? Multiplication, then we multiply. So we are going to get 2 on 5 times 15 on 2. Then we multiply. The top will give me 30, and also the down will give me what? 10. There is one more thing I wanted to look at as far as this is concerned. Multiplication and division is concerned. Now, when we are multiplying fractions, it paves way for us to cancel out. We can cancel out. Now, this is when we can cancel. We have to know when we can cancel as far as maths is concerned. We don't just cancel anyhow. So let's look at this. Now, if we have A over B times C over D, we have A over B minus C over D. And we also have A over B plus C over D. Now, among these 3, let me start from this one. This is addition. Now, with addition, the only way we can cancel is canceling like this and like this. What I mean is, if I have 2 over 4 plus 1 over 3, and I want to solve this, I can decide to break this one down. Saying 2 goes here 1, it goes here 2, then I'll get 1 over 2 plus 1 over 3, then I'll solve. That is the only way we can cancel as far as the sign is addition. If this sign turns out to give 2, we cannot cancel this and this. Is it clear? So the only time you can cancel as far as addition is concerned is like this, vertically like this, and like that. The same thing applies to subtraction. When we are subtracting, we also cancel as we cancel in what? Addition. We cancel like this and like that. We can't cancel like this and like that. No, it's not done. Is it clear? Now, when it comes to multiplication, we have so many ways of canceling. We can cancel like this, we can cancel like this, we can cancel like this, and also like this as well. What do I mean by this down over here? Let's take an example. So if we have 5 on 10 times 2 on 15, if I have this as a question to multiply, I can decide to cancel this 5 with this 15, saying 5 goes here 1, it goes here 3. It is allowed when the sign is multiplication. Also, we can also say that 2 goes here 1 and goes here 5. It can be done. As far as the sign is what? Multiplication. We can also say 5 goes here 1, it goes here 2. It can be done. And also 2 goes here 1, it goes here like that. We can cancel like this, cancel like this. But please, there's no way in math we can say that 5 goes here, let's say this and this and cancel out. So you say 5 goes here, 2, it goes here. No. So we cancel like this, like this, like this, and like this. It is accepted. So this question, the question that we just saw, we could have started by saying that 2 cancel here 1, it cancel here 2. Then we get 1 over 5 times what? 3 on 2 before we solve. We'll get the same answer. We will get the same answer in the broken version. Because if you cancel out this, 2 goes here 3, it goes here 10. That's the same answer we'll get. The same way applies here. The time we change it with this one, as it was changed, if this one changes multiplication, and this side becomes 15 on 2, we can cancel out. We can say that this can cancel this directly. So 2 goes here 1, then it goes here 1. Then we cancel, then we multiply this. 1 times 15, and also 1 times 5 times 1. Then we get our answer. So that is how we cancel as far as math is concerned. There's no other way. I hope it's clear. Okay, so now let's take some Bodmas questions. I'll write about 5 questions or 6 questions on the board. Now I'll solve 2 of the questions with you, or 3 with you. Then the rest, I would like you to solve it yourself, and also send me the answer. We have this question to solve under Bodmas. Now, what is Bodmas? Bodmas simply means that when a question is given, all these signs can be in the question. They are all signs. The first one, the B stands for brackets. The O stands for off. The D stands for division. We have multiplication, addition, and subtraction. And they are steps. When you have a question that involves everything, you start by swapping the one in the bracket first. Then you move to the, if there is off in the question, you move to that. When there is division, you move to that. Like that. You can't start by swapping the addition first before coming to the bracket. You'll be wrong. So let's take this as an example. Now, we have in the first bracket, 2 over 3 minus 1 over 2 of another bracket, 1 over 6 divided by 1 over 2 times 2 over 3 plus 1 over 4. We have to use Bodmas. Now, I always tell my students, the scarier the question, the simpler it is. The scarier the question, the simpler it is. If you see a math question that is so scary, trust me, that question is very, very simple. Now let's look at this. Now we can see that the first one has a bracket, and the second one has a bracket. And with Bodmas, we have to tackle the one in the bracket first. So what are we to do? In the first bracket, we have only one sign, that's subtraction. So we'll just go ahead and write LCM over here. Then off. Now in the second bracket, we have division, we have multiplication, and we have addition. So we're using another Bodmas inside the bracket. So B, we are in this bracket. Now off, there's no off here, but we have division here. So we'll tackle the division first. Now how do we tackle division? We reciprocate this term, the term close to the division. We reciprocate it, then we return the multiplication, then we multiply. So to be like this, 1 over 6 times 2 over 1. I have reciprocated it. Times another 2 over 3 plus 1 over 4. Like that. Then I'll go ahead, I'll multiply this and this to make it go away. So I'm going to get, you see, even here I can cancel this and this, right? I can cancel this and this. So 2 goes here 1, and it goes here 3. So I'm going to get 1 times 1 over 3. 1 over 3 times 1 over 1 times 2 over 3 plus 1 over 4. Then with this side, this for this side. So for this side, we'll get our LCM of 6. Now this goes here 2 times, so I'm going to get 4 here. Minus this goes here 3. That will also give me 3. Now I'm going to get 1 over 6 off. We are not done. Now we will multiply this. But mind you, we have multiplication and multiplication. So we multiply all together. So 1 times 2 will give me 2. Then 1 times 3 also give me what? 9. Then plus 1 over 4. And I put my brackets. Is it good? Then I replace my 1 over 6 off over here. Now this in the brackets here we have addition. That's the next one after the multiplication. So we'll find the LCM of this one. So we find the LCM of this one, and we are getting 36 as the LCM. Now 9 goes here 4 times. Times this will give me 8. Now 4 goes here 9 times. Times 1 gives me what? 9. So this value gives me 17. You are getting 17 on 36. But we are not done. Remember, we also have 1/6 off over here. So moving ahead, we are going to get 1/6 of 17 on 36. Now, what does the off means? It means multiplication. We are going to get 1/6 times 17 on what? 36. Then we are going to get 17 on we are going to get 17 on 216. That will be our final answer. We can't do anything to this thing again. So that's our final answer. 17 on 36. 17 on 216. That is all. So let's take another question again on this. After that, I'll write some questions for you to solve, and you send it to me to check for you. I hope it's clear. Now, let's take this question. After that, I'll give you some questions to try on your own. Please try your best and do it. Try your best and do it. When you send me the answers, I'll check for you. Now, the same way we have over here, we have in one bracket 2 whole number 1/4 minus 1 whole number 5/8 plus 4/8 minus 2/9. So Bodmas, we start with a bracket. Even before the bracket, what we have to do? We have to convert this improper to what? We have to convert this mixed fractions to what? Improper fractions. That's the first thing to do. So let's convert this multiplied by this 8 plus 1, 9. So you get 9 on 4 minus this plus gives me 8. 8 plus gives me 13. So 13 on 8 plus 4 on 8 of 2 on 9. Now we have this. We've not done anything. We just converted these ones to what? Improper fractions. Now, from there, what we have to do? They said the first thing to do is what? Tackle the bracket. So we'll find the LCM over here. So the LCM here gives me what? 8. Right? For 4 and 8, the LCM will be 8. So 4 goes here 2. 2 times 9 gives me what? 18. Minus 8 goes here 1. Times this gives me what? 13. Then I convert with plus 4 on 8. Now, this 4/8, I can break it down. Okay, so that my values will not be bigger. I told you how to cancel. You can cancel like this as well. So 4 goes here 1, it goes here 2. So you're going to get what? 1 on 2. Then off 2 on what? 9. Is it clear? Now let's continue. So 8 minus 13 gives me what? 15 on what? 8 plus 1/2. Now let's look at the off. The off means multiplication. After bracket, we are going to off. So we will change it to multiplication. Then what? 2 on what? 9. Mind you, we can do something here and here as well. We can cancel out because the sign here is multiplication. So 2 goes here 1 and it goes here what? 1. So 1 times 1/1 times this will give me 1/9. So I'm going to get I'm going to get 15 on 8. Then the plus sign will come 1 over 9. Because this 1 over 1, when I multiply 1 times 1, I get 1. When I multiply 1 times 9, I get 9. Now I'm getting 15 on 8 plus 1. Well, we find the LCM here. Now the LCM here is 72. Now 8 goes here 9 times. So 9 times 15 gives us 135. Can you confirm that for me? Then plus 8 goes here, 9 goes here 8 times. 8 times 1 gives me what? 8. So this plus this gives me what? 143 on what? 72. That'll be a final answer. That is so simple. You see, Bodmas is like that. After you tackle the bracket, it will break it down for you. I hope it's clear. So I'll write 4 more questions on the board. Then after that, I want you to copy the questions and also solve them. Try your hands. Do something. Put pen on paper. Try it. You get it. So keep trying. Okay, so now we have some 4 questions on the board. I want you to look at and try your hands on them. Now, the first one is first bracket. We have 4 whole number 3 over 4 minus 1 whole number 5 over 6 divided by 1 whole number 1 over 4 times another bracket 1 whole number 2 over 3 plus 2 whole number 1 over 3. Now, someone will say the question is too complex. Yes, it's too complex, but after you tackle the first 2 brackets, as I said, you tackle the first bracket and the second bracket, the question will come down to your level. But before you even tackle that, you have to first change the mixed fraction. That is you have to change the mixed fraction to improper fraction so that we will all get fractions, not mixed fractions. Then you take it from there. It's so simple. After tackling the bracket, it will break everything down. Now, number 2 says, first bracket, we have 3 whole number 1 over 2 plus 1 whole number 1 over 4 divided by 3 whole number 1 over 2 minus 1 whole number 1 over 4. And with this one too, the same thing. You just tackle the left bracket and the right bracket differently. So after you get your final answer, you just move from there. It's so simple. Now the third one says 3 whole number 1 over 4 over 7 minus 1 whole number 1 over 3 divided by 2 whole number 2 over 5, all divided by 13 over 3 minus 1 whole number 6 on 7. Now with this one, it is just like the question 2, but the division sign was written with a symbol for the question 2, but down here it was not written with a symbol. So you can decide to rewrite it as the question 2, then you solve it. The same thing applies to question 4. We have 3 over 4 minus 7 over 8 plus 1 over 2 all on 3 over 4 off bracket open 7 over 8 minus 1 over 2. This one to the same as the question 3. As I said, you can decide to continue from the numerator, the 1 over 2, you divide it by, then you continue over there, then you solve it, you get the same answer. So I want you to solve them. If you don't have my contact here, it is rolling on the screen. Take it after solving, then you let me know. Thank you very much for joining me today on fractions. There are more to come.